Module 5, Topic 1, Lesson 1. We're talking about the introduction to probability and things that we can do once we are wrapping our mind around what probability is helping us figure out. It's the study of how likely something is to happen. In the previous videos, what we did in those ones was discuss one situation, spinning a spinner. What are the chances or the odds of getting a certain outcome? What we have for this lesson is when we start to layer up multiple decisions and multiple choices. I'm sure you've been in this scenario before. You're at the restaurant, let's say a pizzeria, you're waiting for your chance to order and you're considering all of your options and you know what you want. You know that you're going to order pepperoni, you're going to order extra cheese, you're going to order some other sort of like topping to go with it. But have you ever stopped to consider that there might be pizza choices and options out there that you haven't considered before? For example, Mario's Pizzeria advertises special deals in the newspaper. And in those special deals, we have a choice between a large one topping or a small one topping. And we can choose whether it's square or round, if it has a thin crust or a thick crust. We could also choose between pepperoni or mushroom. Now, this is a limited number of choices in the real world situation. Maybe, you're going to, the restaurant down the street and they offer you 7 different, toppings for vegetables and 6 different toppings for choices of meat, etc. But because of that, we might have flavor combinations that you're just not even considering. And so we want to consider all of those situations that are there. Now, if you notice, I did highlight some of the vocabulary from before in this paragraph. We're working with probability. We're understanding the full sample space of this event. The event is ordering pizza. But in our sample space, because there are multiple choices, we should use something called a tree diagram, later on an organized list, that'll help us provide a visual model for determining the sample space of those multiple events. Let's look at what Amalia ordered, and then we'll compare it to how Romeo sketched out their tree diagrams to show the possible pizza specials at the pizza. Now think about it. What are all of the decisions that Amalia is going to have to make? She's going to have to decide, am I getting a large pizza or a small pizza? That's the first decision. Is she going to enjoy a square or round shaped pizza? So that's the second decision. Thick crust or thin crust, that's 3 decisions. And then available toppings, pepperoni or mushroom. So how many total decisions does she have to make? Well, because there are 4 decisions for those 4 different pizza choices, then we should see those choices reflected as they spread out and populate. And let's, I guess, envision what's going on here with this tree diagram. First choice, she has to decide between a square or a round pizza. Second choice, let's say that this is her scenario. What would you order? I'm going to put myself in Amalia's shoes. I'm going to order a round pizza, and then I have to choose between thick crust or thin crust. Maybe thin crust, right? Thick crust, deep dish sort of thing. Not going for that. Between the choice of getting a round pizza, a thin crust, now I got to choose in this next row of, am I going to choose going down this path? So deciding to go down this path. We're going to get a large pizza or a small. And let's order a small. Keep going this one. And then last of all, pepperoni or mushrooms. I'm not about mushrooms, but I'll be about pepperoni. And so technically that path that winds its way through the tree diagram outlines all of Amalia's decisions. Now it's the entire picture of everything that she could have decided to do, but specifically following one path, one branch, tells us what her choice was. Now, Romeo might have done something a little bit different. Romeo didn't put square and round first. Romeo said his order in this fashion. Putting yourself in Romeo's shoes. Maybe Romeo said, I'm going to order a large one-topping pizza. I want it to also be round. Doesn't have to be completely opposite to Amalia's. They can agree in some decisions. Let's go thick crust and let's go pepperoni. And so if you follow that specific chain of thinking, Romeo was able to produce a different order than Amalia. Dramatically different, maybe, but also unique to his situation. So that's an event for Romeo that's different from Amalia's. All possible decisions are reflected in the tree diagram because every section is it outlines all of the options that are available to the customer when they go up and order. So large and small is found in both of their tree diagrams. whether they put it third or first. That decision must be present in the diagram that they're making. So, check. Square versus round. We need to have the branching options, branching off of a previous choice. And both of them show square and round at various levels. They don't have to be in the exact same order, mind you. Depends on how you phrase what you're going to order. It still allows us to capture the options that are there. Thick crust or thin crust. Both of them have thick crust and thin crust. And then last of all, pepperoni and mushrooms. Both of them have pepperoni and mushrooms. And it makes sense maybe to finish with a pepperoni pizza. How do we say this? I would like a large, round, thick crust pepperoni pizza, please. That's Romeo's order. I would like a round, thin crust, small pepperoni pizza, please. But by doing this tree diagram, we're able to actually capture the entire web of all possible outcomes. So it leads to a choice, a question. How many possible outcomes are there? Well, if we count this final column here, this final column is going to capture all possible outcomes that are available. And I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total possible outcomes. In fact, that'll be my answer for number 1. There are 16 total outcomes. Remember that an outcome, by the way, an outcome is the types of choices that are available to us after doing some sort of like probability arrangement, right? All total outcomes. What are the different choices? So if there are 16 total outcomes, how did we get that? We'll give it a name, but think about it like this. At this level, 2 choices. At this level, 2 choices. At this level, 2 choices. And at this level, 2 choices. So if you take 2 times 2 times 2 times 2, you get 16. 2 choices at this stage, 2 choices at the next, 2 choices at the next branch, and last of all, 2 choices in the final branch. If there were other choices, maybe pepperoni, mushrooms, or cheese, just cheese plain, then we would add another branch here, which would mean all of these final options in the last column would be pepperoni, mushrooms, and cheese, and so we'd add that extra branch, and it'd actually be 3, because there'd be 3 choices in that one. The tree diagram shows us all the possible arrangements of the sample space for, choosing your order for pizza. But it applies in so many other situations. And so let's continue going on. We'll answer some math questions in page 777 related to this advertisement. But I encourage you to think about where you are given the choice in your restaurant, store, etc. decision-making process in life, and think about how many actual choices are present for you through that. Thanks for watching this episode. See you in page 777. We'll learn some more math and talk about more probability at that point. Thank you very much. Bye.